Learn how to instantiate a shared array buffer to permit multiple parallel background threads to seamlessly read and modify the exact same physical segment of system memory. Here's my boilerplate code that want to look at a multi-threaded processing with shared array buffer with an example. I'm ready my script tag and I'm going to first make a variable without a value. So let me call it let's buffer. So the variable is buffer and then it has no value. Now, I want to use a conditional statement here to check if window.cross origin isolated. I'm still going to explain this if you don't understand it yet. Just follow along. Then buffer equals to new array buffer. Sorry, not new array buffer. Shared instead. Shared array buffer. And I'll pass it 16 byte slots. Now, S buffer equals to new array buffer of 16 byte slots. So, once I'm done with this, I can go ahead and then wrap the buffer in a 32-bit integer array view. So, it's time to write to my buffer, to my array buffer. So, I'll make a variable and call it shared view. So, new int32 array, and then pass in my buffer, which is what I have here as a variable. So, now that I've done this, it is time to commit a value directly into the 0th index slot. So shared view. So I'm passing a position. I'm giving it a value of 42. So I just write directly like that into my buffer. So it's time to now read the value back out of the memory. Read the value back out of the memory. And now I'll just make another variable and call it a shorthand for number and call my shared view with an index position of 0. Then I can go ahead and then display results. Document.getElement by item demo dot inner HTML equals to the value inside index 0 is plus number. And now you can see the value inside index 0 is 42. What just happened? Now let's go through this one after the other. Now, window.cross origin isolated. This is a security protection flag because shared memory can be targeted for specialized CPU hardware exploits like Spectre. So modern browsers require specialized security header COOP and COEP enabled on your server to allow a shared buffer to be generated, which is exactly what we are trying to do here. And that is the purpose of this cross-origin isolated. It is a security protection flag. Now, when multiple thread updates the same shared array buffer at the exact same instance, data corruption can occur. So to solve this, JavaScript pairs shared buffer with a companion global utility called atomics, which forces threads to wait their turn orderly. So you can see in this if statement, with this security protection flag, you can see creation of a new shared buffer, and S, another array buffer is to be created. So this atomics is what help us to is what forces threads to wait their turn orderly in order not to avoid crashes. So how does sending a regular array buffer look compared to a shared buffer? Well, observe the difference. When using standard browser post message method communication lines to talk to web background workers, then you will be able to understand the difference between using an array buffer, a shared array buffer, and post message method communication. Although I will not be able to show you an example of how you can use the post message method communication, but you can just dig deep into it to understand it and now compare it to what we have here on the screen, which is what we are currently working on. So this example shows us how to conditionally check if your environment supports shared memory using window.cross-origin isolated. If yes, it instantiates a shared buffer so that any modification made via an array view are accessible instantly without serialization overhead. And to tell you that this works on my own system, you can see that I'm able to generate the result and print it out on the screen. So in standard browser JavaScript, I just want to quickly point out something. The global runtime objects property is written entirely in lowercase, and that is talking about this window text that you are seeing here. So it's referring to the window or self. Now, using capitalized window, that is, if I change the initial to capitalization, the W letter to capital W like this. Now, let's see what is going to happen. Of course, my code is still actually showing the correct output, but using this capitalized window directly as an execution check will throw a reference error. That is, if this that I have here, if it goes directly into execution, this is supposed to give me an error, but it is actually not showing any error. I want to inspect to see if there is something that needs to get. So there's nothing inside the console, which means that at this point, this is checking. But if it is not checking, if it goes directly into execution, then there's going to be a runtime error, which means the code will not run and it will just blow up in the middle or at some point when your code is trying to execute. So take note of this small letter W and capital letter W when you are trying to refer to the global window object in your code. So in summary, we've been able to see that conditionally we can check if our environment supports shared memory using this window.cross-origin isolated. If yes, it will work, and if no, then there's going to be a runtime error or another type of error in our output.